NASA made a big announcement about a long-awaited Mars mission this week. Here is everything you need to know about the status of the Mars Sample Return mission and why this mission is so important to NASA. Mars Sample Return is just what it sounds like, a robotic mission to bring back rock and soil samples from Mars. Every 10 years, different science disciplines conduct what's called a decadal survey, which basically outlines the highest scientific priorities for the next 10 years. For planetary science, the highest priority for 2 decades has been Mars sample return. It is a big deal to this community. That's why the Mars Perseverance rover has been collecting and storing samples since it landed on the red planet. It's in the Jezero crater, which scientists think is an ancient river delta, which means these samples could contain evidence of ancient microbial life. Now, Perseverance is gathering Martian rock and dust samples using its drill, cataloging these samples, and storing some of them on the Martian surface. Some are on the rover itself. The idea is, and this is what Mars Sample Return is, that we're going to send a spacecraft to Mars to retrieve these samples. It is a very complicated mission with ambitious goals, and that's why, unsurprisingly, it's been in trouble. I've reviewed NASA's budget issues previously, but basically, the agency has been dealing with what is essentially budget cuts the past 2 years. As the head of the Science Mission Directorate, Nikki Fox, said at a briefing, Congress's spending cuts have put NASA in this difficult position where MSR in its original form is not feasible. Because of that, many of us have wondered whether the mission will even happen anymore. An independent review board report back in September made it clear that under the planned mission architecture, it would cost around $11 billion, which NASA cannot afford, and the samples wouldn't get back until the 2040s, which is much later than they'd like. This was a complicated mission from the outset, and as the independent review board report made clear, neither the schedule nor the budget were realistic for MSR from the beginning. Basically, the mission architecture involved, first of all, the Perseverance rover, at least that part is done and on the red planet. Then the sample retriever lander was supposed to launch from Earth in 2028, with arrival on Mars scheduled for 2030. It would land and then deploy the sample retrieval helicopters, which would be based on Mars Ingenuity, to collect samples that Perseverance had prepared and stored around Mars. The rover would also return to Jezero crater to deliver samples to the sample retrieval lander. The plan was to bring a rocket along for the ride with the lander, and after all the samples were safely stored, the rocket, called the Mars Ascent Vehicle, would take off in the early 2030s. It would meet up with the European Space Agency's Earth Return Orbiter that would capture and secure the samples and return them to Earth. So, just to review, we're talking about launching a rocket, sending it to Mars, landing the spacecraft on Mars in a safe area, deploying a lander and 2 helicopters to collect samples from multiple sites, ensuring that we store them properly and safely for the medium term, making sure Perseverance is still functional by that point and can travel to meet up with this lander, loading all of this up, and launching a rocket from another planet, something we have never done robotically before, and doing a full robotic rendezvous in Mars orbit, and then having that ESA spacecraft leave Mars, return home, and land on Earth with the samples safe and intact. It's certainly a cool idea, but it is unbelievably complicated, and thus not a surprise that the independent review board found it unrealistic given the budget and the time frame. So now what? Well, at the press conference this week, NASA announced that basically they're going back to the drawing board with Mars sample return. They've made it clear that the mission is still a huge priority for the agency, but that they'd like to accomplish it with a $5 to $7 billion budget. They want it to happen in the 2030s, and while they recognize they might not be able to retrieve all of the samples, they would like to retrieve most of them. They also do not want to cannibalize other science missions like Venus's Veritas mission or Dragonfly. It's interesting because I can't recall something like this happening with a robotic science mission before, but NASA is basically sending out a call to commercial space and industry, other NASA centers, basically anyone who has an idea of how we can accomplish this mission, balancing budget with time frame and with risk posture as well. The solicitation will go out within the next week, and basically by late fall or winter of 2024, NASA hopes to have a path forward. They want out-of-the-box proposals on how to accomplish this mission, but they're not necessarily looking for leaps forward in technology. Instead, they want to go to tried and true tech to lower the risk, lower the cost, and reduce the time frame necessary for designing, testing, and building. This is so interesting for a few reasons. First, it does show how much of a priority Mars sample return is for the agency. If you're wondering, why do we care? Well, basically, everything we know about the moon, we know through either theoretical modeling or direct examination of moon rocks brought back on the Apollo missions. To understand how a habitable planet develops, to understand whether there's life out there, to understand how a lush, water-filled planet like ancient Mars becomes what we see today, we need to directly examine Mars rocks by humans in a lab. To do that, we have to get samples back. But second, this brings up the question of what was NASA looking for in the first place? While these kinds of budget issues and delays happen relatively often with space programs, look at Artemis, which is supposed to return humans to the moon, or JWST, which was first envisioned in the 1990s. Honestly, it's relatively expected at this point. So what went so wrong here that they need to go back to the drawing board now? It's not like Mars sample return is a new idea. NASA's been talking about this since the early 1970s. There have been countless mission architectures, budget cuts, program cancellations, re-evaluations. We've been through the ringer on Mars sample return missions. For this particular mission, though, one thing that is clear is that we didn't know enough about the design of how this tech was going to look and operate. A report from the NASA Office of the Inspector General made clear that not having a stable design for a lot of these pieces this far along into the mission is impacting the ability to create a realistic schedule and cost estimate. The report specifically highlights the capture, containment, and return system, which is designed to capture the sample container in orbit and create a secondary seal for it, as well as sterilize it before returning the sample container to Earth. We're worried about contaminating the Martian samples with Earth stuff, but we're also worried about planetary protection, protecting Earth from whatever might be out there. The design for this part of the mission is behind schedule and over budget. Because there are so many parts to this mission, a delay in one can knock everything off schedule and increase the budget significantly. It seems as though NASA was hoping some sort of new tech would make this mission easier, and that hasn't materialized. So now they're going back to it and looking at the more old, reliable methods and technology, which they probably should have been doing in the first place. And now they're having to start over, basically, trying to redo the mission architecture to save what they can. More than one reporter during this press conference referred to NASA's call for solicitations on MSR as basically NASA hoping for a miracle, and I don't think that's an exaggeration. Let me make clear, I really hope Mars sample return happens. It's a cool mission, the science coming out of it could be amazing. This could be how we uncover the first alien life. I can't stress enough the incredible potential of MSR. But also, I am very curious to see what happens with this, as I am not overly optimistic NASA can find a way to both cut the costs and cut the timeline when they're basically having to start over so late into this. And that's about all I have to tell you about Mars sample return for now. Thanks for watching. I'm Swapna Krishna, and this is Ad Astra.